Good afternoon, everyone. Today we're going to solve a problem using the cosine law, where we're given a non-right angle triangle and we're asked to find the missing angle theta, where we know none of the angles inside the triangle, but we do know all three side lengths. Okay. So you've probably seen the cosine law written as something like a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A, right? And obviously this applies with any labeling of a diagram. And so all we have to keep in mind is that the side length that's by itself here on the left-hand side is opposite to the angle here, my little a and capital A. The angle, capital A, is always opposite of the side length, little a, right? So the angle that we want to work with, we're going to call it theta in this example. We need to have the opposite side length, i.e. 7.5, to be by itself on the left-hand side, right? And now we're going to solve for theta. That will be bunched into the cosine term here, right? So let's write that out. So again, opposite from the angle we're looking for is side length, 7.5. And so we can start with 7.5 squared is equal to the other two side lengths squared respectively, right? When we add them, it doesn't really matter the order, and likewise b times c with multiplication, it doesn't really matter the order, you choose. So I will do 10 squared plus 12.4 squared minus 2 times 10 times 12.4 times cosine of theta. And so that theta is the unknown that we're going to be solving for, right? This is still algebra the way you've always done it, except now your unknown is buried inside this cos term that has other factors alongside it, okay? So let's just work through it one step at a time. So we want to have this by itself in the end, and it's multiplied by these. So this is really one term, right? We can treat that as a term on its own. Let's get rid of the other stuff. Let's move this on the other side, right? And so we'll do minus 10 squared, minus 10 squared. Whoopsies, that's not what I meant to do. I meant minus 12.4 squared rather. So sorry, right? Because we want to cancel out these terms on this side in hopes of isolating the term that has the theta in it. And of course, we always do the same thing on both sides. So minus 10 squared and also minus 12.4 squared. Right? So now this left-hand side is going to read 7.5 squared, what was there originally, minus 10 squared, and minus 12.4 squared, right? Getting rid of the other terms that were on the same side as the term with theta. And now all of that is equal to negative 2 times 10 times 12.4 times cosine of theta, right? So now we have an equation where cos theta is in a term that is isolated on one side, right? So that's a good first start. That's a good first step, rather. But now we also want to get cos theta by itself, right? So we want to get rid of all of these factors that are multiplying cos theta. And so obviously to get rid of multiplicative factors, we simply divide, and so we're going to divide by negative 2 times 10 times 12.4, right? And we always do the same thing on both sides, like so. All of these cancel out, just like we wanted them to. And so now, use a different color, now we have 7.5 squared minus 10 squared minus 12.4 squared. Feel free to evaluate those if you really want to, if you'd rather just have regular numbers. I don't mind leaving them squares. I know I'm going to pop this into my calculator at the end, so I'm just leaving them as is, just to minimize the amount of work I have to do along the way. Do as you please, right? So all of this is divided by negative 2 times 10 times 12.4, and now that is equal to only cos theta, right? That's all that is left on the right-hand side. That's really good. So all we have left to do is solve for theta on its own. And so the opposite of cos is the inverse cos. So to solve this equation, we take the inverse cos of both sides, right? So really to be proper, we're doing the inverse cos of both sides, whereas on this side, the inverse cos of cos theta leaves us with only theta, okay? It's the idea that the inverse cos and the cos cancel each other out, okay? And so now, all we have left on this side is the inverse cos of that whole thing. And the reason I waited until the end to evaluate anything is because we can throw all of that in to our calculator. And this becomes somewhat of a mindless problem. Now, mindless in the sense that we still have to go through the algebraic steps, but we don't have to evaluate any numbers, we don't have to perform any calculations. We can just wait until the end and take the inverse cos of all of that, and our calculator will give us our answer. Now, I'm guessing you were solving for this angle in degrees, so make sure your calculator is set to degree mode, and if it is, and you type all of this in properly, we'll have the inverse cos of 7.5 squared minus 10 squared plus 12.4 squared. Be careful with your brackets also. You might want to put a bracket over the numerator and also separately over the denominator to make sure everything is being divided properly, right? And then take the inverse cos of all that. Super important to put this into your calculator properly. Very easy to make a mistake along the way. And if all goes well, we should get an answer of 37.2 degrees. And there we go. Okay. So feel free to start evaluating any step along the way if it makes you a bit more at ease with how the problem is going. But again, if you're comfortable leaving the squares as they are, so you don't have to actually evaluate anything throughout your algebraic process, it's totally okay to leave it until the end, throw that into your calculator, and out pops your final answer. So I hope this helps. This is certainly the trickier of the two things the cosine law helps us to do. Solving for a side length is a bit more straightforward, and so I'll save that for another example. Thanks for watching.